Hello, India. Hello, IESA. Namaste. Dear ministers, dear industry representatives, dear IESA team, dear ladies and gentlemen, big thanks for having me here at your conference. And I'm super excited to having the opportunity to talking to you about how we, NXP, see the world of semiconductors moving forward, how we see the world of robot building taking up to enable a world that anticipates and automates. And in the next minutes, I try to guide you through this line of thinking. And of course, then this will be hopefully good content to build on for the rest of the conference. What we see globally around us is we're seeing that there is a couple of big megatrends. By the way, pretty old megatrends already. So this slide is not a new slide, it's 15 years old. And these big megatrends are driving industry, are driving society forward, and are driving innovation. And be it on better connectivity, more security, be it on aging populations, shortening of natural resources, all of these areas are driving technology forward. Now, and what are we techies doing in all of those domains? Well, we try to bring the different worlds together. We are trying to bring the automotive world into the smart home world, into the smart health world, into the smart industrial world by building twins. We are getting twins. We are getting digital twins of all of these areas and of ourselves. And these digital twins can start talking to each other. And when they start talking to each other, use cases are coming up that we didn't have so far. Or in other words, we are coming from an on-demand world. Lars wants a pizza, push a button on your mobile phone. Lars needs a taxi, push a button on your mobile phone. Into a world that anticipates and automates. And the Lars digital twin can inform the transportation. Lars needs transportation, or informs the smart home. Lars is coming home, so please prepare the house for whatever is needed. Climatize it, fill the fridge, and so on. So in other words, this is so great because analysts are forecasting that in this world of smart connected devices, there is more than 50 billion of those smart connected devices by the end of this decade. And claim to fame for NXP is we want to be the silicon provider that is able to provide all silicon for all such robots. And then, of course, it's great business, and this is why we are working on it. Now, when you're looking at this page here, you will say immediately, yeah, but Lars, 50 billion smart connected devices, nice, but the form factors are totally different. A smart tiny speaker, a fridge, a manufacturing robot, a car, a plane, how come that you put them all into one pot and say this is all the same type of device? Well, this is how CTOs look at it. So my luxury is, of course, that I can abstract and make it very, very simple how I look at all these devices. And they are all built in a similar way. They are built by sensing the environment, what's happening around me, then connect to the cloud. Can I get additional information and data in? Then you think of a smart advice and send this smart advice to the arms and legs of your little robot. And you do all of that in a way that is trustworthy. So, in nerd language, it is each time, how do I make it safe and secure? And if I would be world champion for sense, think, connect, act, safety and security, I am unavoidable for this 50 billion smart connected devices market. And this is what we try to do. Furthermore, of course, we try to ease the application. So I try to build platforms to scale because what is required is for sure not a one-size-fits-all solution. As you heard, the form factors are very, very different. The markets are very, very different. And you have the requirements to potentially also scale, so to having small, medium, and large devices depending on, for example, in the car market, depending on whether you're in the luxury segment or in the entry segment. Now, what does NXP try to do in these areas? I give you two examples for this robot building. For example, we have exactly these platforms, these Lego blocks for the microcontroller microprocessor area. So microcontroller, small devices, power efficient with embedded memory, to the bottom left here of this portfolio. Then devices that have a microcontroller, microprocessor combination in, so microcontroller very efficient, and big compute centers next to it that can be switched on. Then you have in the green section highly functional, safe and real-time microprocessors that are using external memory, bigger compute units, can do functional safe computations for bigger robots. And then you have big data pumping and display management devices, so our i.MX and Layerscape portfolios and so on. So with that entire portfolio, we have the perfect Lego blocks, finding the right thinking center for each of those robots or for each of the tentacles of these robots. And then what we need to do is we need to also in an efficient way connect those thinking compute centers in your robot and to the outside world. And what we are doing there is we are using connectivity technology, again, as a platform. And Ethernet is such a platform. I mean, you know Ethernet since 25 years from IT industries. What we have done is we are customizing Ethernet since more than 10 years for cars, so to make it functional, safe, real-time, robust. So time-sensitive networking is, of course, the magic silver bullet in cars, but also in planes and in industrial robots. So the industrial segment talks about TSN, time-sensitive networking that is Ethernet-based. And for that, we are, again, you see it in the bottom box there, we are developing devices that are the right physical layers for the different data rates from 10 megabit to a couple of gigabits per second. And you have the right switches, so Ethernet routers, so to say, that are capable of dispatching the data to the right location. So with that, the right networking portfolio and the right microprocessor and micro portfolio and the right power management ICs and analog electronics that NXP is providing, you can start building robots. Now, how do such robots look like? Well, let me start with biology. I'm just looking to what can I learn from history and from biology. And in front of you here on the screen, you hear a biological robot talking to you. And this biological robot has a specific architecture. This robot has a brainstem who operates its extensions, so the arms and legs of the robot. And in the brainstem, in the bottom red part here, my reflexes are located. So ultra-fast, real-time activities. When I stumble, my leg straightens before my main brain, my cerebrum, switches on to understand what is happening. My leg is already straightened again, my body is stabilized. Then, on top of my brainstem, this biological robot has a cerebellum. So a real-time, functional, safe island for robot stability, heartbeat, stomach, stability, temperature control, all done in the cerebellum. And only on top of that, you have an AI center. And this AI center is able to do creative things. Play piano, write love letters, paint pictures. Now, you can ask yourself already, how many love letters do you need from your car or from your manufacturing robot? How important is the functional safety real-time components and how important are the reflexes? And what we see happening at the moment in the industry is the learning is applied, hey, the orange and the green part are unavoidable, and then we can discuss how we scale on the cerebrum. And we see, am I telling you that? We see customers acting with that architecture already again. Leap Motors did 2 months ago a very, very nice announcement where they exactly show that. In the bottom part, you have the functional safety activities, the real-time islands on one PCB, and then you have on top, in a different PCB, the AI accelerators, the SoC. And with that architecture, more customers are running, I would say 80 to 90% of all the robot building customers that we are talking to are working with that architecture. For example, also companies like Applied EV, but also like Continental. They are using similar of these architectures. A lot of it is, of course, NXP silicon based. And this is precisely what you can see in the rolling robots, in the advanced rolling systems for the next years. And you see it here, I tried to map it out where the NXP silicon is. In the bottom, the networking, real-time networking, Ethernet, for example. Then the microprocessors on top that can do the functional safety architectures. And on top of that, you can scale with AI accelerators if you want. All of that about how to build smart, connected, autonomous robots. But that is, of course, not all. What are the other challenges that we see in the industry? Well, one very prominent challenge that we are working is at the moment that we all want to have smart homes. But I can tell you, no one of you has a smart home. We all have connected homes. With all of these devices that you see here on the slide, they are very nicely connected, but they are not talking to each other. And my family, my dad, has stopped buying connected home equipment because he says, hey Lars, my speakers and my window blinders and my fridge and my smart grid, they are all not working, not talking with each other, and I do not even know whether what I buy today is still compatible or usable next year. Just because next year the smart home really kicks in and then I've invested in the wrong way. So what are we doing? Well, again, we are looking back to biology. What is Lars here at the moment doing? I'm talking as a German to hundreds of people in India. And a German would need to translate normally all of the topics that he wants to say into Hindi or the local dialects to address all of you. What have we done? Well, we have aligned on, you know what, it's better, let's talk English as global language, then a German easily can make himself understandable to all the others, non-Germans around him. Switch to a common language. And also, of course, switch to a passport system that Lars even can show. It is Lars who is talking here, and it is not someone else talking, for example, Hitesh on behalf of Lars. So if I only have a relevant passport and can speak a common language, then I can be a respected part of a global community. And this global language and security certification is called Meta. And companies like Apple, Google, Amazon, and NXP and a couple of other founding members have decided to drive this Meta as a language forward. And this language is in the meantime, and Meta certification is used by a lot of connected devices. And these devices are talking on channels like Bluetooth, Wi-Fi, Zigbee, but they talk in Meta language. So think of Bluetooth and Wi-Fi as your phone line, where I call you, and then we talk English over that phone line. That is Meta. And of course, coming back to the selfish NXP view, with our broad portfolio on sense, think, act, and all of that connectivity plus Meta, we can make sure that we can build the robots as I had shown them to you, and that they can make themselves understood by other robots. So, regardless of which type of robots we are building, and this is why this picture of the transformer is here, whether this device transforms into a robot with wheels or without, or a manufacturing robot, I don't care. The architectural transition is key, and these architectures are similar to each other. So if we have architecture clarity, we can move a lot and we can scale. We can and we have to build in trust. Without the right safety and security, it does not work, because you will never allow a system that you do not trust to act on your behalf. And with all of that, we need this platformization, the ability to scale. And with all of that, I am on a fast track to the world that anticipates and automates. And how that world looks like, I just wanted to show you here on my last slide, where you can see what NXP is already doing today. We took your wallet, moved it into your mobile phone. We call it mobile payment. We take your car keys, your keys, and move them into the mobile phone. We call it mobile access, which is basically ultra-wideband enabled access. We have the ability to steer the robots in the right way, to filter news in the right way, and to have the right voice assistants and little robots around us in a connected way, that I can start climatizing my car while I'm still in the kitchen getting my coffee. My car is already preparing for me for my ride. All of what you see here on the slide, you might like it or not, but this is already what we realize today. And of course, this road is accelerating only further. And with that accelerating road to the world that anticipates and automates, I want to leave you now for the conference. Have great discussions along that line. We have an NXP booth at the conference. Please don't be shy to address Hitesh also our booth staff. Drag them into further innovation discussions, especially, of course, around the world that anticipates and automates robot building. We want to be your sparring partners, and I'm looking very much forward to getting Hitesh's feedback from the conference. Big thanks. Enjoy the sessions.